Turkey's rapid rise in the global aerospace industry is no longer a quiet story unfolding behind factory walls, but rather a bold statement of technological ambition. Among the most impressive achievements of this transformation is Turkey's ability to design and manufacture some of the world's largest and most powerful aircraft engines. From advanced military propulsion systems to next-generation jet engines, aircraft engines are often described as the heart of any flying platform. Unlike airframes, which can be manufactured through modular processes, engines require extreme precision, advanced metallurgy, thermal science, and expertise accumulated over many years. But the heart of Turkey's engine manufacturing capabilities is a tightly integrated industrial ecosystem. TEI collaborates with Turkish aerospace industries tie-in research institutions. This network allows Turkey to control every stage of engine production, from design and simulation to casting, machining, assembly, and testing. Large aircraft engines consist of thousands of components, many of which must withstand extreme temperatures, exceeding 1,500 degrees Celsius, while rotating at tens of thousands of revolutions per minute. Turkey has invested heavily in single-crystal turbine blade technology, advanced ceramic coatings, and high-temperature nickel-based superalloys. The process begins with digital design. Turkish engineers use advanced computational fluid dynamics, CFD, and artificial intelligence-assisted modeling to simulate airflow, combustion behavior, and thermal stresses. These simulations allow engineers to optimize engine size, thrust, fuel efficiency, and durability before any physical components are manufactured. Once the design phase is complete, prototype components are manufactured using 5-axis CNC machine, additive manufacturing, 3D printing, and precision casting. Turkey has become a regional leader in additive manufacturing for the aerospace industry, enabling complex internal cooling channels within turbine blades, a critical feature for large, high-thrust engines. Building the world's largest aircraft engines requires manufacturing tolerances measured in microns. Even the smallest deviations can lead to catastrophic failures. Turkish factories are equipped with clean rooms, automated robotic assembly lines, and real-time quality control systems using laser measurement and X-ray inspection. Each engine compressor, combustion chamber, turbine, and exhaust is assembled separately and tested before final integration. This modular approach allows engineers to identify and correct problems early, ensuring the reliability required by military and civil aviation standards. For decades, Turkey relied on foreign suppliers for its propulsion systems. However, changing geopolitical realities, export restrictions, and the need for defense autonomy prompted the country to invest heavily in domestic engine development. These efforts culminated in the establishment and expansion of TEI TUSAS engine industries, the backbone of Turkey's aircraft engine ecosystem. Perhaps the most critical phase of engine production is testing. Turkey operates advanced engine test facilities capable of simulating extreme flight conditions, including high-altitude, supersonic airflow, and rapid throttle changes. Engines are run continuously for hundreds of hours to evaluate vibration, thermal fatigue, and fuel efficiency. For large aircraft engines, test cells are reinforced structures designed to absorb immense thrust forces. Data collected during these tests is analyzed in real time, feeding back into design improvements. This iterative process is essential for achieving global certification standards. Turkey's large aircraft engine programs serve multiple platforms. In the military domain, domestically developed engines power unmanned aerial vehicles, UAVs, advanced jet trainers, and future fifth-generation fighter aircraft. These engines are designed for high thrust-to-weight ratios, rapid acceleration, and survivability in combat environments. In civil aviation, Turkey aims to enter the global turbofan market, focusing on fuel-efficient engines for wide-body and regional aircraft. Additionally, engine technologies developed for aviation are being adapted for space launch systems, naval propulsion, and power generation, further expanding Turkey's technological footprint. Competing with established engine manufacturers is not easy. Large aircraft engine programs require decades of investment and billions of dollars in research and development. Turkey faces challenges in certification, international market access, and long-term reliability validation. However, Turkey's advantage lies in its state-backed vision, young engineering workforce, and growing domestic demand. By integrating education, industry, and defense planning, Turkey is accelerating the learning curve that once took other nations generations to complete. Looking ahead, Turkey is focused on producing fully indigenous, high-bypass turbofan engines capable of powering large transport aircraft and next-generation fighters. Investments in hydrogen propulsion, hybrid electric systems, and sustainable aviation fuels indicate that Turkey is not only catching up but preparing for the future of aerospace. As global aviation enters a new era of efficiency, autonomy, and strategic competition, Turkey's ability to design and manufacture the world's largest aircraft engine stands as a symbol of national technological maturity. What once seemed impossible is now taking shape on Turkish soil, one turbine blade, one test run, and one breakthrough at a time.